Welcome back. So now we are going to go to chapter 14.5, yeah, from your textbook page 213, yeah, textbook page 213. We're going to look at conservative forces and potential energy in this chapter. So what is the objective? At the end of the day, you'll be able to use the concept of conservation forces and determine the potential energies of such forces and apply the principle of conservation of energy. I think you know what is principle of conservation of energy. Energy initial equals to energy final. Yeah, we cannot destroy, we cannot create, but we can change from one position to the other. Yeah, where is the application? Application is really too much of application. Actually, these are some examples. Practically everything around in your life revolves about conservation of energy. Even if you eat a plate of nasi lemak, for example, at the end of the day, the nasi lemak converts to form of energy and also waste. Yeah, so everything around in our life is actually about conservation of energy. Yeah, so the weight of the sack resting on this platform causes potential energy to the stored in the supporting spring. If the sack is removed, the platform will rise. Yeah, will rise because spring always opposes the force that is imposed on it. Yeah, so it's just waiting to actually push this up once the sack is being removed. So that's one example with. Okay, and then this young woman pulls the water balloon under the launcher bag and then releases. So when it's released, what happens? So it will the balloon will be launched. Yeah, launched, and then we have got certain maximum range where the balloon actually can release. This is what we studied in the projectile motion. Yeah, so you have to be careful with the angle that you incline. Yeah, so based on that you can actually hit your target accurately. Okay, next application, roller coaster. Released from rest from the top of the hill, and the roller coaster moves down the hill, and potential energy is transformed to the kinetic. So you have a maximum potential here, rolls down, yeah, goes at the maximum speed down here, gains a bit energy and goes up back and then comes down back. So literally the roller coaster actually, if it's designed properly, yeah, it will actually go in this turn without even dropping here. Yeah, but of course you cannot just suddenly stop. There are some roller coaster now is being modified. Yeah, if it stops up here just to add some thrill into your life, some drums roller coaster, you will have a shoulder harness and also some safety features because this is motorized, so it stops. But in a real fact of roller coaster, if it doesn't lock in here, it will move at the top speed and come down back again, gaining speed again for this second one, and then what do you call, release it. Yeah, so it's always the first one will be higher than the second and will be higher than the third. Yeah, so that's how it goes. Yeah, because of energy transition, and you have conversion of energy into friction. So that's the reason why A has to be higher than B than C. Okay, so now let's go into our lesson of conservation of force. So what we have here, yeah, I think I would just write the summary instead of reading everything to you. Yeah, here. So whatever energy that you have actually studied initially, equivalent to the final. That's it. So we have the potential energy due to the gravity, isn't it, just now? And we also had potential energy due to the spring. Earlier we were combining, yeah, T plus U12 equals to T. So we were actually combining. This part is the combination, but now no. We're going to write T1 V1 equals to T2 plus V2. So conservation of energy. Everything that's initial equals to everything that's final. Yeah. So that's the reason why the same formula is being broken up into two parts. Yeah. MGH initial, MGH final. So it's not like something totally new that you are studying. It's just the same thing. Okay. So we have spring. So now we break it up into two parts. Yeah. So we have what? Spring in the initial, spring in the final. So you split it. Yeah. So weight, everything you split. So this is all the initial forces. This is all the final forces. So this V is actually your U. Yeah, U12. Instead of writing it as a in one place, now you break it up into V1 equals to V2. Okay, it's just the same thing. Okay, I'm going to go into an example. As usual, I will skip the example in these slides because these examples are very, very easy. So you can just study and understand them by yourself. I'm going to go to a textbook example, which is a bit more complicated compared to the slide example. Yeah, it's a bit more challenging. That's the reason why I always pick example from the textbook. Okay, the gantry structure in the photo. So gantry, this test plane, yeah, to test the response of an airplane during a crash. So the airplane having a mass of 8 mg. What is 8 mg? 8 megagram. Yeah, is hoisted back until theta 60 and then pulled back. Cable AC. We have cable AC here. Okay, release when the plane is at rest. Now remember, it is actually at rest. Determine the speed of the plane just it before crashes the ground when the theta is actually 15. Also, what is the maximum tension? What is the maximum tension developed in this supporting cable using the motion? Neglect the size of the airplane and the effect of the lift caused by the wings during the motion. So we are going to actually ignore the drag, yeah, the drag, or in another word, the friction caused by the air. Yeah, we're going to ignore that. Otherwise, we are taking everything. Now, datum. What is datum? We always must set a datum. Yeah, the datum is your reference point where this is the 0 point. So anything below, it depends on you whether you want to set it as 0. I mean, you want to set it as positive or you want to set it as negative. It depends on the question. Yeah, whether you want to take it everything below here as positive or everything below here as negative. Yeah, I'm going to show to you shortly. So from here, you have scenario A and then you have scenario B. So scenario A equals to B and B. Okay, let's analyze this question. It says initially 0. So half mv square initially is 0. What are the forces that is in A? What are the forces that's up here? We have got the potential mgh. Why is this h 20 cos 60? Yeah, because the angle is actually 60. Okay, the angle theta is actually 60. So that is why it is 20 cos 60. And then we have the final force, which is half mv square. Yeah, because it's at the bottom here, right? It's got maximum velocity. That's what we are aiming to calculate. And then we have negative mgh. And this is cos 15. Why is it cos 15? Okay, because if you see this angle, yeah, 1 second. Okay, let me just explain to you about the cos 15 and the cos 60 here. Maybe it's a bit confusing for you. Let me just change the pen color. Yeah, probably we choose a green color now. Okay, what is cos 60 20? Cos 60 20 is this height. Sorry. Good. Drawing with the stylus is not easy. Okay, where do we have here? Okay, straight line here. So this is your 20 cos 60 height. Okay, now 20 cos 15 height is somewhere around here. So that would be the final height from the datum. Yeah, so this would be 20 cos 15. You understand it now? So what is the difference? So this is your initial mgh and this is your final mgh. That's the reason why it is cos 15 and cos 60 initially. Yeah, remember your datum is 0. It's a bit confusing to actually understand because it's a bit easy for us to look at datum which is here and looking everything upward, right? Like what normal, but now it's the other way around. Yeah, okay. So then you can calculate your VB, which is 13.5. Now that is the first part of the question. They are also asking what is the maximum tension developed. So how do you find the tension? Okay, looking at the free body diagram, can you see the inclined angle here, N and T? Yeah, so we will only be studying on the N axis, yeah, the normal axis, yeah, to study to understand what is the tension here. So tension equals to mgh, okay, equals to m an. What is an? Your an is actually your v square over r. Remember normal acceleration? Yeah, centripetal acceleration. Yeah, that's an. Yeah, so with that you can actually calculate the tension of the cable itself. So if you see this a and v square over r, where did you study? You studied this in your second chapter, but you are still using this in the third chapter. Yeah, so that is why it's very important for your for you not to miss any of the classes, yeah, for you to really understand the chapter before that, because the previous chapter will support the final the subsequent chapters. Yeah, so make sure that your foundation is good, you do all the questions, yeah, and you try to understand everything. If you have any problem, then you meet me during the consultation hours and you can ask me all the questions. Okay, so with this we have actually ended chapter 14, or chapter 3. Yeah, so please do all the questions that is given in the study guide. There are quite a number of them. Yeah, self-study questions, and also the what do you call examples that are solved. I want you to redo them so that you have a better understanding of the chapter itself. That's not to torture you, but to make you be better, okay, to understand better. And then I've also requested you to actually solve some what do you call tutorial questions, which will be rewarded marks as well. Yeah, I mean, it's a lot of questions, I understand, but this is actually to make you even smarter. Okay, with that, thank you. We have ended chapter 3. Yeah.